Hello, myself Solanki Ketul and my project is on Newton's law of cooling. The rate of change of a body is proportional to the difference between the temperature of the body itself and that of the surrounding. The Newton's law of cooling can be written in the mathematical form as follows. Further solving this equation we get this where T is the temperature of object, P is the temperature of surrounding, K is constant and the negative sign appears here due to the decrease in temperature. Further solving this equation we come out through this equation. A practical problem of Newton's law of cooling is as follows. A formal statement of the problem. The temperature of a body in a room is 90 degree Fahrenheit. After 3 minutes, the temperature of the body becomes 60 degree Fahrenheit. After 6 minutes of initial, the temperature becomes 50 degree Fahrenheit. What is the temperature of surrounding? According to the Newton's law of cooling, dt by dt is proportional to T minus P. Therefore, dt by dt is equals to minus K T minus P, where K is constant. Therefore, dt upon T minus P equals to minus K dt. So, integrating on both the sides, we get dt upon T minus P equals to minus K dt. Further solving this equation, we come out through this equation log T minus P equals to minus Kt plus C. Give this equation number 1. Now, as stated in the question, at the time T equals to 0, the temperature of object is 90 degree Fahrenheit. Therefore, substituting these values in equation 1, we get log 90 minus P equals to C. Give this equation number 2. Now, as stated in the question, at the time T equals to 3, the temperature of the object is 60 degree Fahrenheit. But before this, substitute this value of C in equation number 1. Therefore, log T minus P is equals to minus Kt plus log 90 minus P. Give this equation number 3. Now, putting these values in equation number 3, we get log 60 minus P equals to minus 3K plus log 90 minus P. From this we can get the value of K equals to 1 by 3 log 90 minus P upon 60 minus P. Give this equation number 4. Also, as stated in the question, at time T equals to 6 minutes, the temperature of the object is 50 degree Fahrenheit. Substituting these values in equation number 3, we get log 50 minus P equals to minus 6K plus log 90 minus P. From this, we can get the value of K equals to 1 by 6 log 90 minus P upon 50 minus P. Now, give this equation number 5. We can compare the value of K from equation number 4 and 5. Therefore, we get 1 by 3 log 90 minus P upon 60 minus P equals to 1 by 6 log 90 minus P upon 50 minus P. Equating this equation, we get 90 minus P upon 60 minus P square log 90 minus P upon 50 minus P. Cutting log on both the sides, we get 90 minus P whole square upon 60 minus P whole square equals to 90 minus P upon 50 minus P. Solving this equation, we get 90 minus P 50 minus P equals to 60 minus P whole square. Therefore, 4500 140 P plus P square equals to 3600 plus minus 120 P plus P square. Solving this, we get the value of P, which is the temperature of surrounding 45 degree Fahrenheit. Here's the answer. We solved the question. Thank you.